Hello everyone, welcome to Ways to Learn. In this session, let me explain how to implement stack operation. Before implementing the stack operation in your code, you must know what is stack and how it should be implemented. Stack is a linear data structure. It is a collection of elements where we can store the data one by one and we can remove the elements or data one by one. Let us see how we can do this. In stack, the elements are inserted or removed one by one in LIFO order. LIFO means last in first out. The element which you are inserted last will be removed first. Consider an example. If you are stacking your books on your table for reading, you can remove your book one by one from the top, not from the middle or bottom. So, and another example, if you are stacking chairs on your hallway, you need to remove your chair from the top, which is inserted last. So, this type of data structure is stack. So stack is a collection of elements. The elements are stored one by one in a sequence and removed in an order from last to first. So in stack, the operations to be performed are push and pop. Push means you are going to insert a new element into the stack, and pop means you are going to remove an element from the stack. So here only one pointer is used in the stack, that is top pointer. Top pointer indicates the top element on the stack. So here the conditions to be checked is, while you are inserting an element, there should be a room for a element to be placed in the stack. So if there is a room, you can place the item. If it is not, you cannot insert an element into the stack. While popping, there should be an element in the stack. If there is no element in the stack, you cannot remove the element. So these are the two conditions you have to check while inserting an element into the stack and while popping an element from the stack. Let me explain you this stack operation with a box. Consider this as a cylindrical box which can hold three items, three toys. Here one pointer is there. That pointer indicates the top item on the box. You had four toys that has to be placed inside the box, and you can place only three toys inside the box. Let us see what are the operations to be performed on that. Now you know how the push operation has to be performed. For inserting an element or pushing an element into the stack, first you need to check whether the stack is full or not. That is the first point. Check the box whether the box has a place to hold another toy. Then if there is a place, you can place the toy by increment the top pointer by 1. So you can increment the pointer and you can place the item. So this is the operation you are going to perform while inserting an element or toy. Top pointer points to 0. There is no element in the box. So here for inserting an element, what we have to do? We have to check the top pointer first. The pointer must not be full. So top is less than 3. And if it is less than 3, you can increment the top by 1. That is top equal to top plus 1. Incrementing 1 and placing the item on the stack. You will place one item on the stack. Now we placed one item on the stack. Let us move to the next insert operation. The same conditions to be checked. We have to check the top pointer. Top pointer is less than 3. So you can place the item on the stack and you can increment the top pointer by 1. In the same way, you can insert the next item also into the box. That is, top pointer is 2 and it is less than 3. You can place an item and increment the top pointer by 1. What happens when you insert a next element into the stack? Now, the top pointer is not less than 3. It is equal to 3. So, you can't place any more item on the stack. So, you have to display the message, the box is full. So, for insertion, you need to check the condition whether the top is full or it has a place to hold an element. And next, you can insert an element. For inserting, first condition checking and then insert an element. These two operations has to be performed while inserting an element. Next we will see pop operation. Pop means removing an element from the stack. Here what are the things to be done is, first check the box whether it is an empty or not. If there is a content, we can take. If there is no content, how can we take? So the same way here, we have to check the box whether it is not empty. If there is an element, you can remove the element. And decrement, this is an important process. You have to decrement the top pointer by 1. Now the top pointer indicates the amount of the count of elements in the stack. Now the top pointer is 3. We can remove an element from the stack. First thing what we have to do is, we have to check whether top is not equal to 0. Top must be greater than 0. Yes, the top is greater than 0. So you can remove an item from the stack and you can decrement the pointer by 1. Now the top pointer indicates the element 2. Now you can remove an element and decrement the pointer by 1. The top pointer is 1. You can again remove one more item from the stack, that is from the box, and you can decrement the top pointer by 1. Now the top is 0. If top equal to 0, there is no item in the stack or box. You can't remove any item from the box, but you can place an element on the stack. So you might have understood what are the operations to be performed on the stack, that is push and pop. And by using the pointer top, you can insert or remove an element. So let us implement this on a code. Now let us go over the question for implementing a stack in C++. To create a class to implement the data structure stack. So here you are going to create a class named stack with a constructor to initialize a top of stack. So you are going to initialize the value top by 0 using a constructor. And with the member functions push and pop, you know what is the operation to be performed in push and in pop. And for this condition to be checked as overflow or underflow. If it is overflow, you can't insert any item into the stack. If it is underflow, you can't delete or pop any item from a stack. So let us see how to write a code for this. Here we have to create a class with a name stack and with a variable top and I for displaying values in the stack. Here we declare the maximum value by 3. Now let us write a member functions. So we will write the visibility mode public. First we have to write the constructor. The constructor is same name as a class name. So mainly the constructor is written only to initialize a variable. Here you are going to initialize a variable top. top by 0. So stack is a name of a class and with no parameters, and we are initializing the stack variable top by 0. Now let us write a code for a push operation. Push operation, we have to check a condition and then insert an element. If the condition is overflow, you can't insert any more item into the stack. So for this, you will use if statements. See here, void push if top is greater than maximum, that is top variable is greater than max, then it is stack overflow. You can't insert any more item into the stack, or else insert an item and increment the top pointer. This is the function for push, and let us see how to write a function for pop. So for pop, the header function is return type and a function name, void pop, and if top is equal to 0, it means stack is empty. If top not equal to 0, you have to display the item and decrement the top pointer. So this is the function for pop. Let us write for a display. For displaying, you have to check a condition whether the stack is empty. If the stack is empty, you can't display the items. Void display top equal to 0. Top equal to 0, then stack is empty. Else, you are displaying the items in the stack one by one. So these are the functions you are going to write on the class. Class, constructor, push function, pop, and display. So these are the functions in the stack. Now let us write the main function for the stack. You are going to create an object for stack, and choice is a variable to input what operation to be performed, that is push or pop from the user. So we had declared a variable choice. Let us display the menu using a do while loop. We had 3 operations, push, pop, display, and fourth we can have it as exit. If choice is equal to choice not equal to 4, then exit. So till that you can perform the do while loop. So let us display the menu first. Menu, and get the variable, that is choice 1 or 2 or 3. Now after getting the input, you have to use a switch statement and display the push or pop operations. Okay, push, pop, display. Okay, so this was the code for stack. So let us run and check whether the code works fine. So let us enter 1 to insert an element, 20. Now we can display by 3. Yes, it displays the item. Let us remove this item. Choice 2. 20 is removed. Let us check the conditions. Now the stack is empty. We popped the element. Let us pop another element. What it displays? Stack is empty. You can't display, pop any more item. So let us check for a push also. 23, 1, 32. Only 3 items you can insert. 42. You had inserted 3 items. Now I am going to insert. Stack is full. You can't insert any item. So we can display them in Okay, 23, 32, 42. Okay, the code is working fine. Let us give an exit. Hope you understood the stack implementation. Please post your questions in the comments. Let us see the stack using pointers in another video. Thanks for watching.